Hello everyone, we are Group 15 and this is the PAWS project, which stands for Personalized Access Weighted System. PAWS is a vision-based smart pet feeder for controlled multi-pet feeding. This is the team. John is an electrical engineering major and he was in charge of the PCB design. I'm Juan Pablo, I am a computer engineering major and I was in charge of the computer vision pipeline along with the mobile app. David is also a computer engineering major and he was in charge of the embedded software. And Juan is an electrical engineering major and he was in charge of the mechanical design of the project.
This is the mechanical design and final assembly for our pet feeder. The complete enclosure was modeled in Fusion 360 using the dimensions of the internal components to ensure that every part could fit and operate correctly. As shown in the exploded view, the feeder uses a modular design. The lower section holds two feeding bowls, to which each bowl is supported by a load cell. To ensure the amount of food being dispensed above the bowls are two independent food reservoirs and dispensing mechanisms allowing each side to operate separately. The enclosure includes internal supports, angled dispensing channels, removable covers, hinges, and mounting points. The compact layout allows the food to travel directly from each reservoir into the corresponding bowl, while providing enough clearance for the moving components. The electronics are integrated directly into the enclosure, including the Raspberry Pi, ESP, and custom PCB. The ArduCam is positioned with a clear view of the feeding area, while the wiring and camera cable remain protected and organized inside the housing. The module was separated into multiple sections for 3D printed. The components were printed individually and then assembled, with the hardware installed into its designated mounting locations. The final prototype combines automated food dispensing, weight measurement, camera, and monitoring. And this was all printed in a PLA that was safe for pets. Thank you.
Hi, I'm John and I'm going to show you the PCBs that we use for our final project. So basically, we end up using two main PCBs. This black PCB has the ESP and the connectors to the other components, and then this green PCB is the power regulator. So basically, we are using a power brick that outputs at 12 volts and 8 amps to the power PCB, and then this power PCB regulates that power to three different pins: the 5.2 that connects to the Raspberry Pi, the 3.3 that connects to the main PCB, and the 5 volt that connects to the main PCB. So this PCB is the same that is right here. And you can see all the connections, everything's connected. And here I'm going to explain what each connection is. So this connector is to connect the load cell directly, and then we have in here the ADC for both load cells. Then we have the 3.3 power pin, we have the PIR sensor pin, we have the two stepper motors connected and running, we have the 5 volt pin here, we have the light sensor pin, we have the LED strip pin, and for this iteration we also included 4 buttons, and then over here there are the buttons. So basically we did that so that we can control the feeder manually using those. And then the first iteration was this PCB, where we had the ESP PCB and then the load cell and the stepper motors in a separate PCB, but since we didn't have a lot of space, we decided to combine that in a single PCB, which is this one. Additionally, the other PCB that we're using is this one over here, which is the light sensor. It has that yellow thing is the light sensor, then a capacitor, and then on the back we have the pull-up resistors, and it goes and connects directly to the main PCB.
I will be showcasing the embedded system portion of the smart feeder. The first thing I'm going to do is show off the lux sensor working with the LED strip. So I'm going to go ahead and turn off the lights. And as you can see, the LED strip became brighter. I'm going to turn the lights back on, and it becomes dimmer because there's more lux in the room. The next thing I'm going to showcase are the buttons. Within code, I made the buttons function as interrupts. So I'm going to show off the lid button. Pressing the lid button once puts it in automatic mode. Pressing it again puts it back into automatic mode and basically in its original state, of course. I'm going to press it one time, and next I'm going to showcase the stepper. I'm going to remove this lid right here, You can see there is currently pet food within the feeder. I'm going to press the stepper down button, and it's going to dispense food, of course. This is the manual function for the stepper, of course. The stepper, as shown, can spin in reverse by double pressing. And this is basically an anti-jam feature. And then slowly but surely food will dispense. Okay, right now the bowls are currently empty, as you can see. And then here, wait for it, 0 grams for the left load cell, 0 grams for the right load cell. And then I'm gonna press the stepper down. After that, 12 grams for the right load cell. You can see the load cell is actually going up in value. And then just hold it right there for a sec. That's registering a button press in the forward direction. The button also moves in the reverse direction, just in case any jam happens. And then we can get a new value for grams, 21 grams. I'm going to show off the PIR firing. I'm going to wave my hand, and then you can see it sent a PIR. This will be important later when we showcase the UART working. And then finally, I just wanted to showcase the lux value is actually changing within code. Right now I'm covering it 0 lux, and then I'm going to reintroduce it. The lux went up, and you can see the LED strip varying, of course. Finally, I will be showcasing the embedded system working with the Raspberry Pi's computer vision. First, I'm going to showcase an unauthorized pet. As shown, the LED strip blinks red because an unauthorized pet was detected. Now I will be showcasing an authorized pet, Mimi. The LED strip turns green and the servo opens.
Hello, I'm Juan Pablo, and I'll be demonstrating the computer vision pipeline as well as the mobile app. Right here we have Mimi. She is one of the authorized pets, and her assigned bowl is the left bowl. So right now, as you can see, the feeder will be flashing red because there is no authorized pet in front of the feeder. However, if we move Mimi in the frame, in a few seconds, the feeder should flash green, indicating that Mimi was recognized and her respective bowl is opened. Now, after her bowl is open, every 5 seconds, it will run a presence check to check if Mimi is still at the bowl eating. So as you can see right now, that bowl is remaining open because it is seeing Mimi on the left side of the feeder. However, if we move her out of the frame, the lid closes. This is Milo, and he is the second authorized pet, and his bowl is the right bowl. So just like Mimi, we're gonna move him to the frame of the camera, and his bowl should open. So, in a few seconds, the right bowl should flash green and his lid should open. And just like Mimi, his bowl opened, and the presence checks are running right now, one every 5 seconds. But if we move him out of the frame, in a few seconds, his lid should close, indicating that he has left the frame. This is the demonstration for the mobile app. So we'll be going over the features of the app, different pages, and what you can essentially do as a pet owner through the app. We'll start off with the homepage. So this homepage kind of serves as a dashboard, a summary of all the features of the app. So at the top, it shows you the feeder status. It shows you the amount of pets that are currently enrolled, as well as the weight of each bowl, so how much food is in each bowl. L, of course, standing for left, and R standing for right. And then as you scroll down, it kind of gives you a little description of the more important information of each page. So the activity page, the pets page, and the device page. And if you click we'll start off with the activity page, you click that, it takes you to the activity page, where it shows you all the recent events. These events are either a pet that has been recognized at the feeder or a scheduled meal that has been dispensed. So as we scroll down, the most recent event is unknown, which essentially what that means is no pets were recognized by the camera. So it sent an unknown event. So either there were no pets at the feeder or there was an unauthorized pet. So it just sends back an unknown. And below that, as you can see, the recent events of the 2 enrolled pets, which are Mimi and Milo. The since the PIR sensor triggers quite often, instead of having all the events filled up by unknown events, we just summarize it into just one. So this one unknown event will be refreshed every time there is a new unknown event. As you can see, the time just changed from 434 to 435. So kind of showcasing what I was just explaining. However, if there is an event for an actual pet, then these will be added to the list. And then moving on to the pets page, here is where you can look at the pet profiles, enroll new pets, and schedule meals. So starting off with the pet profiles, we currently have Milo and Mimi enrolled. If I click Milo's profile, it gives an option to add or change a profile picture and then add more recognition photos. Essentially what this does is it gives the feeder more photos for this pet profile, so it is more consistent and accurate when recognizing this pet. And then if you scroll down, there are input fields for name, the species of the pet, the breed, and then the assigned bowl, either the left or the right bowl. You can save these changes, delete the profile, or cancel. So we'll just save these. Same for Mimi, just really quickly just to showcase. Every pet would have the same type of profile. And then as we scroll down to the meal scheduling, so here you can add new meals or edit new meals. And so just for demonstration purposes, we can add a new one. Click the plus button, you can choose which pet you want the meal to apply to, give a name, so we can say snack, give a time, we can say, I don't know, anytime, 6:30 p.m., and then a portion of any portion, we'll just say 40 grams. So what that means is at the end of the meal event, the bowl should have 40 grams. If for some reason when the meal time arrives and the bowl has equal to or more than 40 grams in this case, then they would not dispense any food as the target portion has been reached already. So we can save this meal, and as you can see, it'll show that it is upcoming, meaning that it is still yet to dispense today. And then we can sort this list by their actual meal time or by the most recently created meal. And then lastly, the device tab. It shows you that the feeder is online, the weights of each bowl, the last motion, and the last schedule dispensed by the pet, so when each pet had their last meal. And that is the mobile app. Now we'll be demoing the meal scheduling through the app and seeing how the feeder responds to the scheduled meal. So right now, the right bowl has about 45 grams of food in it, so that'll be important for when we schedule the meal. As you can see, for demonstration purposes, we have opened the right lid just so we can see the food actually being dispensed into the bowl. And now we can create the meal. So right now it is currently 12:58. So we'll call this meal demo, and then we'll put 12:59. Specify that is AM. And then the portion we can say, we'll put about 65 grams. And then we will save this meal. And then when it reaches 12:59, as you can see, the time has reached 12:59, and now it is waiting on the device to actually dispense the food. And once the food is dispensed, it will return to the back end, and the app will pick that up, saying that the food has been dispensed. So if we look, the food should dispense shortly. And as you can see, the app now updates and it says dispense today. If you go to the activity log, it'll show that Milo added 22 grams to the right bowl. And if you go to the weight, it says around 66. So right now, the right bowl just opened because Milo was in the frame of the feeder. Now he is approaching the bowl and eating out of his respective right bowl. After the lid opens, it will perform its presence checks. So right now the lid is remaining open because Milo is being recognized and eating out of the right bowl. Right now Milo is eating out of his respective right bowl. However, he just left, and since he left, the lid should now close. So it has to fail 2 consecutive presence checks and then it closes. So Mimi has approached the feeder. So she is now in the field of view of the camera. So the feeder should shortly recognize her and open her bowl, which is the left one. There she is. However, if we move her out of the frame, sorry Mimi, the bowl then closes.